Okay, so in your Google Classroom, I want you to go under classwork, find Lab 3. You'll see that there are two things posted with Lab 3. There is a Google Sheet, which I would like you to open up. It looks like this. And then there's also a link to a website. The website is where we'll be collecting our data today. I'd like you to open up this lab as well. This is the simulation that we'll be using to collect our data with. I'm going to walk you through what we're doing in the lab, and then I'm going to just say, collect all your data, fill in all your data tables. That's it. That's all you're doing today is getting the data tables constructed. If we have time, we'll work on making the graphs, but we will not answer any questions today. I'm leaving that for Monday. We have a long time together on Monday because of the assembly that's happening. And it's a period 2 assembly. So it's an extended period 2. So we have like almost 2 hours together on Monday. Okay. So figure we can do the lab on Monday. All right. We'll finish then. So I'm not in a rush to get this done, but I do want to show you what you're going to do in the lab. So does everybody have the Google Sheet open? Okay. You'll notice on the bottom of the Google Sheet that we have several different tabs. All we're going to be looking at today is, of course, the directions tab, so we know what the heck we're supposed to be doing. Then we're going to look at the experiment 1 tab, the experiment 2 tab, and the experiment 3 tab. There is another tab over here on the right for analysis. That is Monday. That is Monday. So don't even bother looking at that tab right now. Let's go back to the directions tab, and let's just look at what you are being tasked with. The first thing I need to do is give you a little bit of background information. This lab is called the pendulum. So it begs the question, what the heck is a pendulum? A pendulum is something like this that can swing back and forth. Okay. This lab is about what's called a simple pendulum, which means that at the bottom there's a mass. The string is considered to be massless. Have any of you ever encountered a string that has no mass? No, they actually don't exist. Okay, so this is a theoretical situation where we'd have a massless string and a object with some mass suspended from the string that doesn't have any mass, which doesn't exist in the real world. That's why we're doing a simulation with this. We pull it back to a certain angle. And in order for this to be classified as a simple pendulum, not only does the string not have any mass, but these angles have to be really small. If the angle is too big, we pull it like way back like this and allow it to swing. It doesn't follow what we call simple harmonic motion. The angle, it starts twisting around. It does all kinds of weird vibrational things. So what we're going to do is just pull a mass back to a small angle, which you'll be told what that angle is. We will be adjusting the length of the pendulum from a pivot down to the center of the mass, and then we'll be adjusting the mass at the bottom of the swing. And what we're going to be doing is timing it as it swings. Watch up here, please. We're going to time it as it swings from here out and back 10 times each time. So we're going to count it 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. That's what you have to do. You're going to count 10 of those out and back. I'm not saying count it out once and back is number 2. It's got to go out and back is 1. You follow what I'm saying? That is called, when it goes out and back, that's called a period. But we count them 10 times because when we try to measure that time on a stopwatch, if you were to do it just for one swing, your reaction time is going to affect the data that you collect. So by spreading it out over 10 of these swings, your reaction time doesn't have much of an effect. And that's what we're trying to do, is collect good data in this lab. Let's see if there's anything else here on this. Yeah, let's just look at the procedure here. So I do want you to open up that website, which I had linked. If you already opened it up, here it is. We'll talk about that in a minute. And it says that we want to start by clicking on the intro button on this page. So can you all please click on intro? And this is going to allow us to collect the data that we need in this lab. Okay, this particular screen. I want to go over setting certain things with you that it tells us to set. So the first thing says deselect the ruler, but select the stopwatch. So here on this screen, you see over here on the bottom left, it has ruler already checked. Uncheck it. We don't need the ruler. I do want you to select the stopwatch. Now, this is our stopwatch that we're going to use. And let me just show you how it works. If you pay attention up on the screen, you'll see this little arrow pointing to the right. That starts it. And then to stop it, just click that button again. All right. So what I just measured right now was a time of 1.57 seconds. To reset it, you hit this reverse arrow and that resets it back to where we want. There are some additional settings that we need to go through. We are going to adjust the parameters of mass, length, and angle to construct the specific pendulums that are described on those 3 experiment tabs at the bottom of this Google Sheet. So I'll show you how that's done. And then it tells you to measure the time for 10 full swings out and back with the stopwatch in the simulation. And then you're going to record that time out and back for each experiment. Do not type in anything else into the Google Sheet. It gives you a yellow column to fill in with those times for 10 swings, and that is all you're filling in. Don't adjust anything else. The Google Sheet's going to automatically calculate the period for you. Remember, the period is the time out and back once. You're going to do it 10 times, and then the Google Sheet will automatically divide it by 10 to give you the period. And then what we'll be doing when we are all done collecting the data is we'll be making some graphs together. All right, and I'm going to show you how to do that because the graphs don't come out the way we expect, the way we learned the other day. There's a lot of modifications that have to be made. So I will walk you through that once we have all the data collected. All right, any questions? All right, so let's go to experiment 1. We have to look at what we're going to do. In our first experiment, we're going to be looking at data table 1-1. And it tells us in cell A3, row 3 of this experiment 1 tab, that we need a mass of 0.1 kilograms, an angle of release of 9 degrees, and a length of string of 0.60 meters. Let's all construct that together. Okay, so let's go to the pendulum lab. To adjust the mass, you'll see here on the top right, there's a mass option. I want you to go ahead and adjust that mass down to the mass that I stated, which was 0.1 kilograms. So you can use the slider bar to move it all the way back. There I have my 0.10 kilograms on my slider bar. The next parameter I need is, let's adjust the length of the string to 0.60 meters. So the length would be adjusted here on the top. Let's adjust that back to 0.60 meters. I can do that with the arrow buttons as well, or I can just drag the slider bar until that length says 0.60 meters. Okay, we are not going to adjust anything else. Now, to pull it back to the angle that they want you to get an angle of 9 degrees. So if I look at this tab, do you see how there's a protractor on here? If I pull it back, I click on the mass. Do you see now it gives me an angle measure on the top of the screen? Right now it's saying 0 degrees. I'm going to pull it back to the left, and let's go to the right so it's a positive angle. And I want to pull it back until it says 9 degrees. Okay, then you can just release it, and you're going to see it start swinging. Okay, there is a delay between what it's doing on my computer and how it's being displayed up on the screen because of the Bluetooth between myself and the projector. So you should see it on your screen, just swinging back and forth nice and evenly. Yes? Okay. So what I'm going to do now is you can just let it keep swinging. We have to start our stopwatch at the moment it reaches a high point on either side. And I'm going to do that on my screen. If you want, you can watch up here, or you can try doing it yourself on yours. And hopefully we all get roughly the same time as we count it going back and forth 10 times. I know because of the delay, it's going to be a little hard to see up on the screen because of that delay, but here I go. Ready? Go. There's 1 swing, 2, 3, 4, 5, 6, 7, 8, 9, and stop. Okay, so what I just got, can you see right here? That's the time I just achieved for 10 full swings. If you did it, you should get something similar to that, around 15.55 seconds. What I'm now going to do is take that time, 15.55 seconds. I'm going to go to my Google Sheet, and I'm going to type it in here in that yellow box. You can type that in with me as well. You don't have to replicate that trial. You're going to do all the others. I'm going to allow you to partner up with somebody. So if you want to partner up, you can split and say, I will do this data. You have 2 other tables you have to complete. One on experiment 2, you have to construct these pendulums, get those times. And in experiment 3, you have to construct these pendulums and get those times. So you want to, I'll let you pair up with the person sitting next to you, figure out how you want to divide it. I'll do experiment 1. How about you do experiment 2? When we're both done, we'll meet up and split experiment 3 in half. Something like that. Okay, that way we can collect the data a little quicker. All right, sound good? Shouldn't take you too long to get the data. I'm going to freeze my window so that way you're not seeing me collect my data. Well, I guess it really doesn't matter. I'm going to go ahead and start collecting on my own. I want you to go ahead and divvy it up with the person sitting next to you. And then once you have yours, you'll just share it at the end. Okay? Change the past. Let me restart that. Stop. One. 1.3. Okay, 0.7. Three and 0.6. Okay. 1, 2, 3, 4, 6, 7, 8, 9, 15.5, 7, 9, 6. Six, 7, 8, 9, 15.60. 12 degrees. 1, 2, 3, 4, 6, 7, 8, 9. Oh, I missed it. Shoot. 6, 7, 8, 9, and stop. 15.59 and 15. Six, 7, 8, 9, and stop. 15.52. All right. You're all still collecting data? Yes? Okay. I'm on my last experiment, so hopefully you're getting close to wrapping up as well. 0.79 and 1. Six, 7, 20.12. Okay, now change the 0.8. One, 2, 3, 4, 5, 6, 7, 8, 9, and stop. 17.8. 0.6. Six, 7, 8, 9, and stop. 15.59. 0.4. 1, 2, 3, 4, 6, 7, 8, 9, and 10. 8, 6, 8. 7, 9, 2. Three, 4, 5, 6, 7, 8, 9, and stop. 9.6. All right. Once you've collected all the data, all your data tables are done, you can close this simulation. You will not need it anymore today. We'll need it again on Monday, but not today. So I'll just wait for all of you to finish getting your data, and then we'll go back to experiment 1. Mm-hmm.
What should be like the margin for like error?
What do you mean margin for error?
Like how many swings?
Like every time you're counting 10.
10 swings. And like seconds, how many times?
It's all based on your reaction time, but you should have a pretty fast reaction time. You're young. Yeah, if you're seeing a variation of more than like half a second from trial to trial to trial, something's wrong. It means you're not paying attention. And let me know, because I will make sure the New York State Department of Motor Vehicles knows, so that way you are never behind a wheel of a car. Because if you have a long reaction time, that's not good. You see the lights on somebody's car in front of you come on, they're stopping, you got to slam on your brakes. More than half a second to move your foot from the gas to the brake pedal is bad. That's really bad. You're going to have an accident. So, no, you should be paying attention to what you're doing and stopping it as quickly as you can. Again, once you have all 3 data tables completed, you and your partner have talked to each other and copied each other's numbers over, then we can go ahead and start working on making the graphs. And we're going to make them together because they are not going to come out as nicely as they did with the lab and the practice Google Sheet exercise I gave you the other day. I don't know why Excel gives us a hard time with these ones, but it does. Excel. Google Sheets gives us a hard time with these. Who still needs more time to collect data? Okay. Give you a couple more minutes to get those 3 tables done. Who still needs more time? Okay. So Josh, why aren't you raising your hand? You're working with Alex, right? You're sharing data. All right, are we good? Yes? Okay. Okay, can we all please look at experiment 1? I'm going to walk you through how to make this graph. Because we are not going to use the first data table on the page. You see it says data table 1-1. We are ignoring that now. I want you to go down to data table 1-2, which is titled period versus mass. And you see that here? Here are the periods and the masses. We're going to make a graph of this data. So please all put your cursor in cell A10. Hold down your shift key, right arrow over to cell B10, and then right arrow down until you get to cell B15. So now in your name box here, you should have A10 colon B15. Everybody good? Okay, go to the insert chart menu. And this is the graph it gives us, which is not complete. Okay, we have a lot of changes to make. First, what we need to do here for the title. Remember, titles of graphs do not include units. So in the customize option of our chart editor, go to the chart and axis titles window, change the chart title to delete those units. We never put units in the title of our graphs, ever. Never, ever. Okay, next thing I need to look at. I have both the X and Y axes labeled. That's good. But the next thing I'm supposed to look at is, do I have a clearly defined 0 on my horizontal axis? And I do not. You have to add that 0 to the horizontal axis. And the way we do that is under the horizontal axis menu, you're going to come down and set the minimum value to 0. A lot of you missed that in yesterday's lab. You need to make sure you do that for every graph. Make sure that there is a clear 0 on the horizontal axis, so there is a clear vertical grid line at 0 on the x-axis. All right, now the data is there. We can go ahead and add our trend line. And when I look at that, if I were just to take my finger and trace from dot to dot to dot, I expect that this is going to be a line, yes? It all looks like it's pretty close to the same value. So to do that, we're going to go down to the series submenu. I'd like you to add the trend line by clicking the trend line option. Select linear because that is a linear, should be a linear trend line. And for label, please add use equation. Just like we learned how to do the other day. Okay. Everybody got it? Any questions? You need me to go back and go through any of that? Yes? No? I've got my reading glasses on, so when I look at you, everything is blurry. The only thing that's clear is my computer screen, because that's what I'm reading. When I look at you, everything's blurry, so I can't see if you're nodding yes, you need me to go through something. Raise your hand if you want me to go through something again. Okay, then please click on your graph and drag it down on the page. You'll see that there is a yellow box here for you to put this graph in. You're going to move that graph into the yellow box that says graph for experiment 1. So when I shrink my window, let me shrink it even more so you can see. When I do this, do you see how that graph is entirely in that yellow box? That's where I need you to place it. Okay? Everybody good with graph 1, period versus mass? Okay, I want you to try the graph for experiment 2 on your own using the same technique I just taught you, using the data in table 2.2. I'm going to freeze my screen, and once we complete this graph, we'll check it. I'm not showing you how to do it. You got to figure out how to make this graph yourself. You should be able to make it yourself at following the same steps I just taught you in the last experiment. Anyone need more time to make this graph for experiment 2? Okay, I see a couple of hands. So quickly try to wrap that one up, and then we'll check to make sure that graph is correct before we try the one for experiment 3. Are we good now? Anyone still need more time for this graph? All right, let's check it. Here it is on the screen for you. So your title should just be period versus angle of release. You got rid of the units. The X and Y axes were already labeled properly, but you had to add that 0 on the horizontal axis. When you add that 0, then you get this vertical dark grid line for the Y axis. You need that there. Then you should have added a linear trend line along with the equation for your trend line. We're not all going to get the same equation because we don't all have the same data, but it should be similar. Any questions on this graph? All right, you want to try number 3? Try number 3 on your own. This will be the graph of period versus length. So here you're really going to have to think about what type of trend line is it? Is it linear or is it curved? And the way you figure that out, remember, is try to connect them with your finger. If you're not sure, go between the 2 different types of trend lines we're allowed and see which one hits more of the points. What are the 2 trend lines we can pick from? Linear and power series. Which one hits more of the points? And that is your better fit, whether it's a line or a curve. If you're not sure, talk to your partner and see if they can give you some clarity on what they think it is and why. Anyone need more time for this graph? You got it? All right, let's check it. Should have selected the power series curve. Okay. So, title, period versus length of string. Got rid of the units, right? You had to clearly add the 0 on the horizontal axis. So now we see that dark vertical grid line here. Both axes are already labeled. You add the power series trend line, and then look, every point is on that curve. And then you add your equation for it. And that's what your graph should look like. Any questions on the graphs? How much time do we have left? Like 5 minutes? Yeah, we got 5 minutes. We'll stop there. We're going to answer the questions on Monday. So do not turn in this lab. I do want to talk to you briefly about yesterday's lab, though. So yesterday's lab, I did grade it. You saw your grades. A lot of you were trying to correct things last night, sending me emails overnight. Anything that you've corrected and resubmitted, I have already regraded and given you a new grade. When I regrade a corrected lab, you have 1 chance. I don't regrade it multiple times. If you want to correct it, that's fine. In a Google Sheet lab like this, any virtual lab, when you go to correct it, you don't need to meet with me. I gave you comments, address every comment that's in the lab, and you'll get half credit back. Do not resolve comments in the labs. Otherwise, I have to regrade the entire thing from scratch. As I regrade it, I will resolve the comments to see if you actually address my comments. Otherwise, if I have to regrade it from scratch, now you're opening yourself up to, oh, maybe I find something else that was wrong. All right. So that's why I say, please do not resolve comments in a virtual lab. If you've already done that, I can reopen them. I think you can do that too if you go up into the comments history of the lab. If it's a paper lab and you want to correct it, you will have to meet with me because I can't let you take home the lab. Does that make sense? Oh, because if you lose it, now you got to redo the entire lab from the very beginning, collecting data and all that kind of stuff. So those would be corrected with me. You would email me to try to set up an appointment. You give me some dates and times that work for you when you want to do it, and we'll see if we can find a time. Correcting the lab usually doesn't take very long. It takes maybe 10 minutes tops. To do it virtually, you do it at home, and then you just resubmit it. I get an email when you have resubmitted a lab. So you don't have to say, I fixed it. I'll know it because I get an email saying you resubmitted the lab. And then I will just regrade it. I'll give you a new grade and put the new grade in Aspen. You will never get all your points back. You only get half the points back. If you want all the points, you got to do it right the first time. Make sense? It's only fair. So what is your homework for next week? You want to work on finishing up the review packet for Tuesday, pages 21 to 24 in your Unit 1 packet. On Tuesday, we'll go over the review. Wednesday, we take our tests. On Monday, we are going to finish this pendulum lab and then start Unit 2. We're going to actually start real physics on Monday. Okay? Claudia, do you want to take this on the graph? You just need a ruler and a pencil. And I'll write you a pencil. Okay. Yeah.